3.7 Transformations of Polynomial Functions. So in this video we're going to identify symmetry in polynomial functions, and we're also going to transform polynomial functions. So first of all, let's get some definitions out of the way. When we call a function an even function, so when we're talking about polynomials and we're calling something an even function, that is completely different than even degree. So even degree, we're looking for the highest power of x and seeing if it's even or odd. An even function means that it is symmetric about the origin. So a function is an even function if it is symmetric, not the origin, by the way, about the y-axis. Right, so if I can plug in x and the opposite of x and I get the same y value. So for example, I come over here and I plug in 1 and I plug in -1, I get the same y value. If I plug in, I think 1 was actually right here. If I plug in this x value and the opposite of that x value, I'm there. If I plug in this x value and the opposite of that x value, I have the same y value. It's the same height. That makes the function an even function. If it's an odd function, it will be symmetric about the origin. The origin is 0, 0. So it will be symmetric around 0, 0, which means if I plug in a x value and I get a y value, let me write it a different way. If I plug in an x value and I get a y value, it doesn't matter if it's positive or negative, I'm going to get the opposite of both of those over here. So I'm going to get -x, -y. This just means the opposite. So if I come up here and I plug in, let's say this is our second point, x2, y2, so I've pulled this point, then I know that the opposite of this is down here. This will be the opposite of x2 and the opposite of y2. All right, so they are completely opposite. You could also think about it from geometry as a 180-degree rotation. So if you remember doing rotations, that would be a 180-degree rotation. So about the origin. So if I take this, if I draw a line through this first point and I rotate it, that goes through the origin, and I rotate it, it's going to land on top of that one. Same thing with this one. All right. If it's neither even nor odd, then neither one of these things will work. So like where I have x, y, the opposite of x and the same y, like neither on this graph, neither one of these two will work. So if I choose like, this point, and I go the same distance over here to the left and try to pick up that same point, it's not even on the graph, right? Or if I try to get this point in the opposite, not even on the graph, okay? So that's one way that you can tell. How do we prove algebraically? So if they give us some graphs, how do I prove algebraically? All right, so number one way to prove, or the way to prove algebraically, is plug in -x, or the opposite of x. So remember, up there I was talking a lot about opposite. Plug in the opposite of x, and here are your options. You're either going to get exactly the function you started with, you're going to get exactly the opposite signs. So all the signs are going to be opposite. So case 1, case 2, all signs are opposite. Or case 3, mixed signs. Can you guess which one matches with which? So if I get exactly what I started with, so that means like the same y value, right? So this is an even function. If I get all signs are opposite, that would be an odd function. And if I get mixed signs, that's neither. All right, so let's see about these guys down here, what happens. So I'm going to plug in the opposite of x. So I get 7 times negative x to the 5th. Let me use a different color, let's do. So I get 7 opposite of x to the 5th minus 3 opposite of x to the 4th plus the opposite of x minus 1. Okay, so let's see what happens. So 7 times the opposite of x, that would be to the 5th. That would be 5 negative x's multiplied together. If I multiply 5 opposite or negative x's together, it's going to spit out a negative, first of all. 1, 2, 3, 4, 5 negatives keeps it negative. And then x times x times x times x times x gives me x to the 5th. So I have 7, negative 7, x to the 5th. So that sign is opposite from what I started with. I started with a positive 7. I'm at a negative 7. All right, this next one, I have negative x times negative x times negative x times negative x. That's 4 negatives. That's going to make that positive. And it's x to the 4th because x times x times x times x is x to the 4th. All right, so this sign is the same. So I already know this is neither. I'm going to continue finishing here. So I have this changes to opposite of x minus 1. So let's just look at our signs. So I'm going to circle the ones that are the same in blue and the ones that are opposite in red. All right, so negative 3, negative 3, positive x, negative 1, negative 1, 7, negative 7, positive x, negative x. All right, so that would be mixed sign, so that one is neither even nor odd. Okay, let's check out the next one. All right, so I have x to the negative x to the 6th, or the opposite of x to the 6th. So I'm going to plug in g of the opposite of x. So I have the opposite of negative, or the opposite of x to the 6th, minus 3 times the opposite of x squared plus 5. All right, let's clean that up. So if I have 6 negative x's, that's going to make it positive because I would have 6 negatives. 1, 2, 3, 4, 5, 6 negatives. So that's going to make this a positive. There's a negative on the outside. A positive x to the 6th. You don't need the parentheses anymore, really. But when I simplify that, I multiply my negatives, multiply my x's, and I get a positive x to the 6th, but I had that negative on the outside here. So I'm going to leave that there. Then I have a minus 3 x squared, because negative x times negative x changes to positive, and x times x is x squared, plus 5. Exactly what I started with. Negative x to the 6th minus 3x squared plus 5. That's an even function. So that's how you prove that a function is even, odd, or neither. All right, stop, pause the video, and you create an odd function. So what would it take to create an odd function? So go ahead and pause the video. All right, now that you're back, hopefully you created a function that had odd exponents only. The coefficients don't matter, but the exponents do. All right, so I need for all of those signs to change. So when I plug in the opposite of x, I need an odd exponent. So I have an odd number of x's so I can preserve that negative sign. All right, so what is the shortcut for polynomials? This is for polynomials. For polynomials, I can look at the exponents. So I know before I even start this work if it's even, odd, or neither, because if they are all even exponents, it's even. And that would include a number. A number has an even exponent. So if it's just a 5, it's x to the 0. 0 is an even number, right? All odd, I would have odd exponents. No number hanging out by itself. And a neither is a mix. All right, so that's a shortcut. Still have to prove it algebraically. All right, last thing. We're going to revisit these transformation of functions. So with quadratics, we looked at responsibilities in a transformation of A, H, and K. A, if it's negative, it flips the end behavior. It flips the graph over the x-axis, which changes the end behavior. It changes everything else too, by the way, but we can think about end behavior also. All right, it also stretches vertically. A stretch or a shrink. So just a reminder on that, a stretch happens when A is bigger than 1. A shrink happens when A is between 0 and 1. So like 1/2, 1/3, etc. All right, H moves left or right. I have to set this equal to 0. K moves up or down. If there's a number in front of x, it's a horizontal stretch or horizontal shrink. All right, what are the transformations that move g of x from its parent function? So first of all, we need to think about the parent function. To find the parent function, I let all the numbers go away, negatives, all the things. So I'm ignoring this negative -6 to the, -6, and this -2. That would leave me x to the 3rd, and that is my parent function. All right, so there's the parent function. So pause the video and see if you can figure out how it's been moved. All right, so I know A is -1. So A is -1, so it's flipped over the x-axis. H is 6, so it moves right. And remember, to find H, we take that out and set it equal to 0, and that tells me movement left or right. And then K is -2, so it's been moved down 2. All right, so that is how we figure out transformations. We'll talk more when I see you again.